It says graph this function and tell whether it's removable or non-removable. So it has a discontinuity at x because if I were to plug, or at 0, because if I were to plug in a 0 on this one, I would have, in other words, f of 0 is equal to 1 over 0. That makes it undefined, so it's discontinuous. There's a discontinuity when x equals 0. So now you just graph this one and then determine if it's pluggable or not. So I'm going to clear out my graph, and I'm just going to graph 1 divided by x, and then I'll just do a zoom, the standard zoom. That should be fine. And I think this is an infinite discontinuity. Now, a pluggable discontinuity, so if I graph this on my graph, it's going to kind of look like this, and like this, right? Is that removable or non-removable? Well, it's non-removable. The reason it's non-removable, every once in a while you'll get one like this, where you have your curve and a hole like that. So this one right here is definitely non-removable because there's nothing I can do to plug the hole. Okay? But this one way over here, I could simply plug the hole by filling it in. So this one is removable. So if you see a graph on the test that when you put it in your graphing calculator, and there's just like one little hole there, that's removable. Because what I would end up doing is I would say f of x when x does not equal c, or whatever it is, wherever the hole is, and I would make a piecewise function that would say, you know, like if this is c and then this is a, I would say just let a be the value when x equals c. Right? Now, they're not asking you to do that. They're just asking you to determine what is removable and what is non-removable. In this case, this particular graph is non-removable.